dragging Fluent into the workspace. Let it finish downloading. Right click on geometry to change it to 2D. Right click. We're going to open up the design modeler. Okay. I'm going to use the XY plane, normal to. We're going to sketch a rectangle. There we go. Let's try dimensioning it again. This is going to be my 100 millimeters and my 2 millimeters. Perfect. Now we're going to go to concept, surface from edges, apply, select it, control, click the edges, and it's a little different from the tutorial. This is what worked for me. I'm going to apply that and generate, and there's my geometry. Alright, going back, we have a green check mark so we can open our meshing up. Okay, here is my geometry. I'm going to come into this mesh and insert an auto mesh, apply, and I'm going to generate that. Should just give us our basic up and down lines. Yep. I'm going to go back in here and insert sizing, edge select, so from left to right, to apply it to this section, change the type to number of divisions. For my left to right I did 100 divisions, and then to make the behavior hard, to turn this off, and then we have the option to change this to hard behavior. Perfect. Now we generate. This will give us our tortoise shell looking mesh. There it is. And insert another sizing. I have edge selected. Now it's top and bottom. Apply to this section. Same thing. I'm going to change the type to number of divisions. Up and down, I did 200 divisions. Come back to turning off the capture curvature so we can change the behavior to hard. Perfect. Now we're going to generate. This should give us almost a complete black block, or just regular meshing where you could see. Yep, just like that. So one more time, we're going to insert face meshing. In this geometry, we're going to apply that. Generate. Now it'll be a solid black block. And if we click this, we can zoom in and see that. That's what we want. And now we're just going to name the sides. Make sure you have edge select still. Name this one inlet. This is going to be named outlet. This is going to be named upper wall. And this is going to be named wall. Okay. We're going to go back to the workbench and update the mesh. Green check mark, so now we can open setup. sure we have double precision checked. Start. Okay. Loading. I'm going to go and exit out of my mesh real quick just to keep my computer running. Open Fluent up. Okay, so for the Poisseuille, I'm going to go to models and make sure that this is a laminar flow. Okay. Materials, fluid to air. We're going to change our density to 1. And for Poisseuille, our viscosity is 1e to the negative 5. Change and create. Close that out. Go to our cell conditions. Just make sure it's taking air. Good. Come to our boundary conditions. So this is going to be inlet. It's going to be velocity inlet. That's what we want. Now for the Poisseuille flow, the velocity that worked for me was 0.2 meters per second. Close. Now we're going to come to our lower wall. Just make sure that it's stationary. And it is. And our upper wall is stationary as well. Then our outlet is a pressure outlet. And for this one, prevent reverse flow is what worked for my situation. Now we're going to come down to reference values and make sure that it's computing from the inlet. Come down and make sure that all those values are correct. Come down to calculation and change our number of iterations to 200. And now we are going to initialize and calculate. And there's our graph with our iterations, and our calculation is complete. So we're not going to close out our Fluent because that's what we're going to go back and edit for the other cases. Let's open up our results. Okay, we're going to make this normal to, and we're going to insert a contour. Just leave it named like that. All domains, it's going to be symmetry 1. The variable is going to be velocity u. Oh, I didn't apply this. Maybe I need to apply the contour. Alright, same thing. We're going to change this to velocity u. It's going to be symmetry 1. We're going to apply. Okay, this is our Poisseuille flow contour. We're going to come down to our legend real quick and change this up to horizontal. And then we're going to change this to fixed. Perfect. Now we're going to insert lines. It's going to be our midpoint. Okay. 0.05. 0.5. And if we take off our contour, see the midpoint there. We're going to insert another line. This is going to be our end point. Okay, it's going to be right before the end. So I change mine to 0.99, 0.099, 2. And I forgot to change this on the other one, but the number of samples made the line a little bit more smooth for the chart. Let me go change that for the midpoint. 100 samples made the chart smooth. And now we can see our endpoint there. Come to our chart viewer. Oh, 1 second. Let's stay here. I'm going to click on chart. Select velocity chart. the velocity profile, Excel flow, data series, so the midpoint, location is the midpoint, midpoint, I'm going to get my lines in there. And come back, change our x-axis to velocity u, the y-axis to y, and now apply. And for our lines, we can see that the endpoint is right on top of the midpoint. Now we can see our midpoint line. And this makes sense because if we come back to our velocity contour, we can see that at the midpoint and at the endpoint it has the same velocity profile. If I wanted to go ahead and add a line at the beginning, this would be the underdeveloped line, which I believe I added in my screenshot just to show there we go. 0.001, 0.002, 100 samples, apply. So now we have a line there. Turn the contour back on, we can see that it's definitely in the underdeveloped area. So when we come back to our chart, we can add the underdeveloped line here. When we apply this, we can see that turbulent area, turbulent slope on this Poisseuille flow. So now I'm going to go back, uncheck that, apply. This is the velocity profile at the endpoint and the midpoint. I'm going to go back to Fluent and make this a Couette flow. So to do that, we're going to go back to our air. I had to change my viscosity to 0.4. Just what worked for me. Density stayed the same. And then when we come down to our boundary conditions, we changed our inlet to a pressure inlet. Yep, and we just left it exactly how it was. And we're going to come to our upper wall. And this is now a moving wall. So the speed that we used for the moving wall was 2 meters per second. I'm going to apply that and close it. Now I'm just double checking that the outlet stayed as a pressure outlet with the prevent reverse flow, and that the lower wall is still stationary. And it is. Perfect. Now we're going to come down to reference values and make sure that we're still computing from the inlet. We can see that the viscosity change and the velocity is 0 for the inlet because it's a pressure inlet now. Come down, we're going to initialize and calculate. Okay, calculation is done. There we go. And there's the right chart. And the same way as before, we can uncheck the endpoint and see that the midpoint and the endpoint are at the same, which makes sense because it is fully developed at both points. Now, if we wanted to show the underdeveloped area like before, now we can see this is the velocity profile for the underdeveloped area. Okay, so this is the graph we used. So now let's go and show the mixed case. So the density stays the same. I kept the viscosity the same for this case, so that's good. I'm going to go into our boundary conditions. What we're going to change is that the inlet is now a velocity inlet. Okay, and then I had the inlet velocity was 1 meters per second, and I changed the upper wall velocity to 0.75 meters per second. Just checking that the outlet, so pressure outlet, and that the lower wall is still stationary. Yep. So now we're going to come to our reference values and just make sure that it's calculating from the inlet.
Would you like a bifocal weight?
I'm recording my video. You're good. And now we are going to initialize and calculate. Perfect. Calculation complete. And now we are going to go into don't think it did. Velocity profiles are getting better. These are getting better. This is the velocity profile that I got for the project for Poisseuille, or for the hybrid flow. It's got a big red area for Poisseuille and the top, the boundary layers at the bottom, with the top plate moving. Not too sure why it's not working now. My graph came out that the midpoint was on top of the endpoint again because it's consistent all the way across. And towards the beginning, here's the underdeveloped line just to show that at the beginning the flow is not fully developed. So when we're here, we need to export our data. We can do this by pulling it out as a CSV. It'll export it as a Excel. And this is where I pulled the data needed for the maximum velocity and maximum height.